Okay, it's time to look at the unit circle, one of the most fundamental concepts in trigonometry. A great deal of what we're going to learn after this is based on observations that we make from the unit circle. So it's very important that we have a good, thorough understanding of the unit circle and what the numbers on the unit circle represent and how to use them. So let's begin. First of all, we need to review a little bit over the special right triangles. This first one I've got that I've drawn up here is a 30, 60, 90 triangle. Now remember, the 30, 60, 90 triangle has this property. And notice here the hypotenuse is 1. The side opposite the 30-degree angle is always going to be half the hypotenuse. Now, in this case, I've just chosen the hypotenuse to be 1. If it were just anything, 3, then the side opposite would be 1/2 of 3. If it were 4, 1/2 of 4, 2. Now, the side opposite the 60-degree angle is the square root of 3 over 2. It's 1/2 the hypotenuse times the square root of 3. So the side opposite the 60 degree is 1/2 the hypotenuse, in this case 1. So it's 1/2 of 1 times the square root of 3. So that's what we need to remember, because when we construct our unit circle, we're going to refer back to this. Another one of our special right triangles that also I've assigned the hypotenuse to have a value of 1 is the 45, 45, 90. Now, of course, remember that the sides of a 45, 45, 90 triangle, if the hypotenuse is 1, would be the square root of 2 over 2. These two things we're going to use to construct a unit circle. These two triangles and their properties. Now, let's go ahead and look at a unit circle. Now remember, when we say unit circle, what we're saying is a circle with a radius of 1 unit. So we call it a unit circle. It just has a radius of 1 unit. Now we are going to divide up this unit circle, each quadrant of this unit circle, into 3 sections. For example, the first quadrant is going, and they're going to be related to those special triangles. So on the first quadrant, we're going to divide it up into a 30-degree angle, a 45-degree angle, and a 60-degree angle. So let's look at that. And we divide each quadrant up that way. So you notice that each quadrant has these 3 divisions. Now, notice what I'm going to do. First of all, notice that I'm going to put a 30 degrees right here to coincide with the fact that this angle that's formed by this first line forms a 30-degree angle. Now, when you make a unit circle, generally what I do is I go through by multiples of 30. So I go 30, 60, 90, and so forth. The 60-degree angle corresponds to this next segment. And then you keep going by 30. So this would be 90. Then you add 30 onto that and get 120. And you always skip the middle line, because we're going to find that those are multiples of 45. The next one will be 150, and then, of course, 180. So notice what we're doing. We're going 3, 6, 9, 12, 15, 180. We're counting by 30s, multiples of 30. So I add 30, and you get 210. 30 more, you get 240. 30 more, 270. 30 more, 300. 30 more, 330. And finally, at the very end, you get 360. Now that's from us multiplying through by multiples of 30. Going through by multiples of 30, I should say. Now, the next thing we want to do is go through by multiples of 45. So we start here with 45. Now, the next place, 45 more than 45 is 90. Well, we already have a 90-degree angle there, so I'm not going to relabel it and have 290, so I go to the next one, which is 135. So we go 45, 90, 135, add 45, and we get 180, which is already there. So we add 45 onto that, and we get 225. Add 45 onto that, and you get 270, which we already have. So add another 45, and we get 315. And once again, if you add 45 to that, you get 360, which we already have. So notice, all of the degrees are either multiples of 30 or 45. So we go through with 30s, then 45s, and we have all of the degree measures. Now we want to do the same thing with radian measure. But of course, the radian measure that corresponds to 30 degrees is pi over 6. It's 1/6 of half of a circle. So I have 1 pi over 6, 2 pi over 6, which reduces to pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, 5 pi over 6, and finally 6 pi over 6, which is just pi. Then we come on through, reducing when we can. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and finally 12 pi over 6, which is 2 pi. Now, the last thing we want to go through with the radian measure that corresponds to 45 degrees, which is pi over 4. Now, we've got 1 pi over 4, and then we come up to 2 pi over 4, which is just pi over 2, which we already have. The next angle, if we add pi over 4 to it, would be 3 pi over 4, and then 4 pi over 4, which is pi. 5 pi over 4. 6 pi over 4, which we already have, 7 pi over 4, and then finally 8 pi over 4, which we already have, which is 2 pi. Now, at this point, we have all of the degree measures and all of the radian measures that are associated with this unit circle. And we've chosen to work with these numbers because from the special triangles we can figure out some things about these. In other words, we know, because of working with the 30, 60, 90 triangle, we know that the side opposite the 30-degree angle is 1/2 the hypotenuse. The side opposite the 60-degree angle is 1/2 the hypotenuse times the square root of 3. So we can start to put the ordered pairs where they should. We can start to name these points where the segments connect to the unit circle. For example, here. Notice that this square root of 3 over 2 and 1/2, that corresponds to this point. That's the coordinate of that point. Now, where did the 1/2 come from? Well, it's the height. This angle, where this 30 degrees is, that signifies that this segment and the axis make a 30-degree angle. So this height here is the 1/2. Now, what about the square root of 3 over 2? Well, it comes from the horizontal. Okay, so if you go over a horizontal distance and up, you get that point. So we have that point, the coordinates of that point, are the square root of 3 over 2 and 1/2. Okay? Now, if you notice, this point has some symmetry with a point directly across at 150. Except for the sign. So notice, if we know that point is the square root of 3 over 2, 1/2, then the point associated with 150 degrees is going to be negative square root of 3 over 2 and 1/2. Because obviously the x value is going to be negative over there. Now also there's some symmetry down with 210. It's going to have the same value of x, the same value of y, absolute value that is. However, the signs are going to be different. So if we look down here, we see that we have the same ordered pair with differing signs. Negative square root of 3 over 2, negative 1/2. And likewise over here at 330, we have square root of 3 over 2 and then the y coordinate is negative. So notice the similarities. All we found the ordered pair for the 30 degrees, and then we could use symmetry to find 3 others. Now let's look at 45. Okay. Now, once again, the square root of 2 over 2 came from the fact that we're looking at the height. Okay, so we've got a 45-degree angle, and we're looking at the height from the x-axis up to the 45. And then we've got the x, which is the horizontal length. And that horizontal length is the square root of 2 over 2. So that's where we got the square root of 2 over 2. Now we can use symmetry as before and find the ordered pair for this 3 pi over 4, the ordered pair for 5 pi over 4, and 7 pi over 4. And notice the only difference in these that have a denominator 4 is the sign. You've got square root of 2 over 2 on every coordinate that's associated with a 4 in the denominator. The only difference is the sign. Now, let's go ahead and look at the 60 degree, the pi over 3. Notice square root of 3 over 2, once again, is the height. And the 1/2 is the horizontal length. So you have an ordered pair of 1/2, the square root of 3 over 2. And of course, there's going to be symmetry to correspond to the 120 degree, 2 pi over 3. The 240, 4 pi over 3. And the 5 pi over 3. Notice every denominator of 3 on the radians has the same ordered pair, just different signs. Now the only thing left to do is to get the coordinates that are associated where the circle touches the axis. First one here, we've got 1, 0. Then we've got the 90 degrees, 0, 1. The 180, negative 1, 0. And the 270 is 0, negative 1. Now that is the unit circle. That's the complete unit circle. When someone mentions the unit circle, this is what they're talking about. Now there are some tricks to being able to draw this quickly. You notice that, first of all, noticing the symmetry, and then noticing that you go through by multiples of 30, then you go through by multiples of 45. Also notice this. On the right, going away from the axis, you have sort of a pattern here. You've got the square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. And then when you're coming back down, the square root of 1 over 2, square root of 2, square root of 2 over 2, square root of 3 over 2. Notice always, if you start with the right and go away from the axis, it follows that pattern. Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and then back. Square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. Recognizing that pattern enables you to real quickly fill in the ordered pairs. In other words, you don't have to, let's suppose you forget that the side opposite the 30 degrees is 1/2. Well, if you remember that pattern, that can kind of reinforce what should go there.